Okay, so welcome Math2526. So last class we discussed the sampling distribution. So sampling distribution is about the sample mean. Like if we take a sample, then sample's average or sample mean will follow this normal distribution. Right? So X bar follows this normal distribution. Okay. Okay. So here, this is like if we assume we know mu and sigma, like if we know populations information, then we can find the information for the sample, right? So let's say from population, so here, if we have the population, if we know the populations mu and sigma, then if we take sample, then this sample mean X bar will follow this normal. Okay, so this sampling distribution is from population to sample. But in real situation is we don't know mu and sigma. We only know X bar, right? So from X bar, from sample, we wanted to estimate from samples information, we wanted to estimate this mu and sigma. So this is our first task in statistics. So we call such things as estimation. So today's topic is estimation. So estimation means from samples information to estimate populations information. Like typically we want to estimate the mu, right, or sigma. So first one just wanted to estimate this mu. Okay. Now suppose like we have those data, right? Suppose like we just have our first exam. Okay, so in our class we have those data. Like we have the exam score like this. Okay. So then we wanted to estimate the performance for all students, for all people. Like we know the performance in our class. Then we wanted to estimate the performance for all other people, other class, right? So now let's consider in our class we have those information. Our class we have 25 students, and our class X bar is 86. So average for our class is 86. Then we wanted to estimate the average for all. So this is a typical statistical question. From sample to population. From our class, we wanted to estimate the whole school, right? Whole university, just like that. Okay, so how can we do that? Okay, so we just start from sampling distribution. Okay, so sampling distribution says X bar will follow this normal distribution. Okay. Okay, so mean is average for all is here, but this mu we don't know. So if we take a sample, we can find X bar. Sample mean X bar may be here, or maybe here. X bar can be here, right? If we take a sample, the X bar can be here, can be here, can be here. We don't know. So, but the only thing we know is that this X bar will follow in such a normal distribution. So from normal distribution, we have this 68, 95, 99.7 rule. So meaning X bar is in this range, like 1 sigma, in this range 68%, or in this range 2 sigma is 95%, right? Or 3 sigma 99.7%. Okay, so we have this like x bar between like mu so extend 1 sigma, so here sigma become this. This is x bar sigma here. This sigma here, right? So x bar between mu plus. So here just x bar is mu is here. So extend to 1 sigma. So here's mu plus sigma over radical n. Here sigma minus. So in this range is 68. And 2 sigma now extend to, let's say like here, mu is here. Okay, so if 1 sigma, 2 sigma, then this part count for 95%, right? Okay, so here we focus on x bar. Okay, we suppose we know mu. If we know mu is here, then we can know x bar in this range is 95%. But the story is our purpose is we wanted to estimate this mu. We know x bar, not mu, right? So here we have mu and sigma, mu and x bar. So this mu is average for all people. This is we don't know, unknown. So this x bar is our samples average. So this x bar we can know this. So x bar we know, right? So our purpose is for mu. So let's change this. So here we focus on x bar, but we want to change this to focus on mu. So let's say, so we just change this like so x bar less than mu plus sigma over radical n. So this inequality we can change this to x bar minus sigma over radical n less than mu, right? So these two inequalities same thing. So we can change this to this. So mu larger than this, x bar minus sigma over radical n, or so here this one like a mu minus sigma over radical n, this is less than x bar. We can change this as mu less than x bar plus sigma over radical n, right? So from here we can get this. So these two statements same thing, but here we focus on x bar, here we focus on mu. So we can say mu between this, so we say mu between this range. So here mu is like here, x bar is here. Then mu is in this range. Such a chance is 68%. So same way we can change this statement like this one. Change this statement to here. So we say mu is in this range. So mu is like, so cent is x bar. So in this range, extend to like 2 sigma, like x bar minus this, x bar plus this. So this is 95%. So we can say the probability or the chance of mu is in this interval is 68%, and mu in this interval is 95%. So we can say we have 68% confidence to say mu is in this range, in this interval. And we have 95% confidence to say mu is in here, in this interval. So we call this interval as a confidence interval. Okay? So this one is 96% confidence interval, and this one is 95% confidence interval. Okay? So in general, we have thus. So at the first we say we call those interval as a confidence interval. So let's say the confidence interval is set at x bar. So because x bar we know this number. Okay, so like in this range is 68, in this range 95%. So we put them together is x bar like plus this or minus this. Okay, so here we use, so extend here as 1 sigma or 2 sigma. So we put this together as this formula. We say x bar plus or minus C star times sigma over radical A. So here we can put this as like as x bar plus minus sigma over radical A, right? Or this one we can put this x bar plus minus 2 times sigma over radical A. So here's 1 times sigma over A radical A. So here's 2 times this. But in general, we say there's Z star, there's a coefficient multiply sigma over radical A. Okay. So now let's consider there's a problem. So if like in our class we find we have 25 students. So here n equal 25. So this n we call the sample size. Sample size. So we call this is a sample size. Okay. And from this sample, we find x by this. So this is sample mean. This sample's average. So here sigma we don't know. So here assume we know sigma is this. Then we can estimate this mu. Right? So estimate means find the confidence interval for mu. So here we want to find 68% confidence interval for mu. So this mu is just the x bar plus minus 1 times sigma over radical A, right? So we just plug in here, so x bar is 86 plus minus, so sigma at 5.2 over radical A, 25. So this equal just the 86 so plus minus so 5.2 over 5, right? Okay, so for interval we prefer the answer is an interval. So we prefer the answer is like from low bound to upper bound. Okay, so here low bound is 86 minus 5.2 over 5.2 over 5. So let's see. So here we can use this for calculation. Little bit calculation we can use Excel or use calculate. So let's see. This equal like 5. Okay. So let's see. So we find this equal like 84.96. and let's see. So okay, so 87. So we can say we have 68% confidence to claim the average for all people were between like 85, 87, 84.96 to 87.04. So we'll be in this range. So if we want to find 95% confidence interval, we just change this to 2, right? So this equals just 86 plus or minus 2 times us, 5.2 over 5. So this equal, so here just a little bit of calculation. So low bound this number, upper bound is this number. So we can say the average for all will be in such interval. Okay. So we say those kinds of problem is easy, right? So let's check this example. So here problem is we want to construct a 95% confidence interval mean. Okay. So here we just check it out. At the first we use formula x bar plus minus, so 95%. So there's coefficient 2, right? So sigma of radical A. So then we just check what is x bar, what is sigma, what is A. So here let's check. Okay, the problem. It just says standard deviation this. Okay, so this is sigma. Yeah, standard deviation sigma is this. We wanted to find a 95% confidence. Oh, here I should put interval, 95% confidence interval. So landing, okay, based on the basis of a landing sample of size 30. So here n equals 30. When the sample means this, so this is x bar, right? X bar equals this. So once you pick up those numbers, then find the confidence interval. Just use the formula, easy, right? So equal. So here x bar is this. So plus minus 2 times sigma 89.75, and so square n is 30. So here just a calculation. So low bound is this minus 2 times this, and upper bound, so low bound is minus, upper bound is plus, right? So here, so the calculation, if those calculation, if we use a computer, so you can use Excel, so really quickly you can find them. Okay. Okay, so here we say in those examples, like for confidence interval, confidence level, we say this 95% or 60% is confidence level. So for this confidence level, we usually from our example is like 60, 95. Okay, so because 68, we know this is this is 1, 68, 95. Okay. So how about okay? So we can do those things like 68. So let's put x bar. So plus minus. So here 68 is 1. Sigma radical a. So here we just plug in here, right? So like we find our class average is x bar is 3.1 plus minus sigma. We assume sigma 0.3 and the sample size 25. Right? So you can find lower bound, upper bound, and the 95% is, let's say, like so 7.1 plus minus 2 times sigma and radical n. Okay. So this percentage means I have confidence to say there's probability, the probability for my conclusion is true. Okay, so here this like 60% means I made this conclusion. So the probability that my conclusion is correct is 68. So this means I have a 32% chance to be wrong, right? So 32% chance that my conclusion is wrong, and 60% chance that my conclusion is correct. So usually this 32% chance to be wrong, this percentage is too high. Okay? So people maybe will do not believe me. Right? So here 95% chance is 95% chance my conclusion is correct. So this means I have 5% chance to be wrong. So this 5% chance is not so big, so people will accept this. So for confidence interval, like for confidence level 68, 95, we prefer 95, right? Okay, so this is, we can say this is probability or chance that my conclusion is wrong. So I hope this number is smaller is better. So how about this one? Like I have 100% confidence. 100% confidence is my conclusion correct, and this means 0% chance my conclusion is wrong. So I want to guarantee my conclusion is absolutely true. So this sounds good, but this is usually, so if we wanted to make a conclusion without any mistake, then we almost cannot make any useful conclusion. Like here, suppose I wanted to give out in 100% confidence interval for mu. So here mu is GPA, right? Average GPA. So I can know GPA mu is between 0 to 4, right? So such a conclusion is no mistake, but we say useless. Okay, so this is useless. So for confidence level, we cannot set this confidence level was 100, and also maybe cannot set the confidence level as 68. So we say the confidence level should be this is better, about 95%. So by default, it's 95%. Okay, or around the 90% is maybe is also okay, right? Okay. So we say the confidence level should be about 90% or 95% or 90%, 95, or even like 98%, or I have just a 2% chance to be wrong, but it cannot be 100%. Okay. Okay. So we say if this is 68, we should not use 60, like 68% and 95%. Then this coefficient Z star is 1 or 2, right? Then how about the general? Like if we have percentage, like here, we want to find 80%. So what is, so suppose 80% or 90%. Then what is this coefficient? What is this Z star? Okay. Okay. So at the first, like what is Z star meanings? So how can I find this Z star? Okay. So now let's consider this, like we want to find an 80% confidence interval. So this Z star actually thus from standard normal, this is 0. We want to find an interval such that this count for 80%. Then this number, this cutoff point is Z star. Okay. Okay. So once we understand this, then we can check the standard normal the Z table, find the Z star. Okay. So our Z table is all the way down, right? Like this. So here, this is Z star, meaning like from here to here is 80%. Okay. So this means here's 10%, right? 10% here and 10% here. So all the way down means, okay, all the way down should be 90%. So we need to check this star is 90% or 9000. So we need to check from the table, check that cutoff point such that this is 9000. Okay. So let's check the table find 9000. Okay. So where's 9000? Okay, so we find 900 is here. This is close to 9000. Okay, so corresponding to this probability, we find this cutoff point is 1.2a, right? So this is our Z star. Okay, so we say here this Z star equal 1.2a. Okay, so if we want to find or give out an 80% confidence interval, we just use this formula. So formula is same, x bar plus minus Z star sigma radical n, right? So here we know this x bar is 3.1 plus minus, so sigma 0.3 n 25. So only thing we wanted to find is just this star. So here this star is 1.2a. 8, then sigma 0.3, so let equal 25, right? Okay, so once you find this star, so then this calculation is really easy, right? So we can easily find low bound, upper bound, so we can get this 80% confidence interval. Okay, so now let's check this like so how about the 90% confidence interval? So it's also easy, right? So 90% confidence interval. So 90% means okay, like this is 90%, 90%. Okay, so this cut point is over this star. So this is 90%. Then here is 5%, right? 5%, 5%. So all the way down. So let's think all the way down is 95%. So we should check this 9500. So then check this cut point, right? Because this way go up. So 9500. Okay, so not check 9000. Okay, 95 should be. So this is the point. This is something you should be careful to make sure this check not 90, check 95. Okay, so 95, 9500. So we can say 9500. 9500 is here, right? So 9500. So we find both of them the same distance to 9500. So we can pick either one is okay. So we find the cut point is 1.6, 1.64 or 1.65. So here this star can be this star can be 1.64, 1.65. So if you put 1.64 is okay, 1.65 also okay, right? So this confidence interval is just the x bar 3.1. So plus minus. So z star. So suppose I put 1.64. So then sigma 0.3 and n 25. Right? So here just you do those calculations, right? Low bound, upper bound. Okay. So we say find the confidence interval. The only thing is just find this star. So the key point, you make sure you know how to find this star. Okay. So we say this star from this table. Okay. So so let's say, so here we say, if let's say for 95% confidence, we know this star, we can use 2, right? So 1 sigma, 2 sigma, 3 sigma. So we can, so other way is, so this is, we say this star equal to by people's experience. But more precisely, we can check the table. So let's check this. Check from the table, what is this star? Okay. So 95%. So let's say at the first we say 95%. 95% confidence interval is from here to here is 95%. So this is over this star. So the only thing we should be aware of is we cannot check 95 because the table is giving me all the way down, right? Let's say, so 95, so then this part is 2.5%, right? Other side 5% on both sides, so 2.5% here, 2.5% here. So all the way down is 97.5%. So 97.5%. So we need to check this non-probability equal 0.9750. So from the table, we should check this 9750. So that one is our cutoff point. So let's check. Okay, so where is 9750? So we just check the table. Check nine. Let's say 9750. 9750. 97. Oh, we find we have exact one. Okay, 9750. Right? Okay, so the cutoff point from this probability is 1.9. Go up is 6. So from the table, we find this cutoff point is 1.96. So here, so for 95% confidence, we say that this star we can have two answers. Can be 2 or 1.96. So we should say more precisely, we should pick this star is 1.96. But if we pick 2 is just the closer one, right? We prefer integer, 1 or 2, 3, right? We prefer integer. So for integer, we just say 1.96 is just close to 2, right? So later on, if we want to find 90%, 95% confidence interval, you can use 2 or 1.96. Okay. Okay. So today's topic is estimation. So first question estimate, we wanted to estimate population's average mu. Population average mu. So from samples average. So from samples average, just like that, from samples average x bar, we wanted to estimate the population's average mu. So we can do two things, like we can say, what is mu? Mu equal x bar. So we call those as a point estimation. Point estimation. But this point estimation, people feel not so happy. Like we only know population's average, like for our other people's other class average cannot be exactly equal our class average, right? But we can say will be close to our class average. Like so, will be like in the neighborhood, like our class average here. Then we can say, other people's average may be in here or here or in this, in such a range, or such an interval. So we perform this estimation. So such estimations we call interval estimation. So this interval is called a confidence interval. Okay. So using this formula, we actually can just need to find this star, because from the information from the sample, we know sample size n, we know samples mean x bar, right? So and this sigma. So here temporarily we assume we know this sigma. Then we can find confidence for mu. So here we just assume this sigma is known, but in real situation, sigma is unknown, right? Sigma is unknown. So our first class is we just make things simple. We assume we know sigma, then we can do this calculation, or we can estimate this mu out of this. So we say, so how about mu sigma is unknown in real situation? Sigma is unknown. Then in this situation, so how to estimate mu? So this will be our next class topic. Okay. So today's topic is just this formula. So I hope this is easy to understand. The only thing a little bit confusing is how to find this star, right? So like how can we get this star from the normal table? So again and again we emphasize this sigma, this x bar, not x bar, this star is the cut point for this one. This is cut point of this star. Okay. Okay. So we can stop today's class. Okay. So thank you. See you next.